Let's talk about points of intersections. Suppose you have two linear lines, let's say one f of x equal x plus 1, and g of x, another line, equals minus x plus 3. Notice that the slope of f is positive, the slope of g is negative, so they're going to intersect at some point. And we want to find out at what point they are intersecting. Of course, you can always graph and look at the graph and use your trace button. But let's say if you want to do this algebraically without using a calculator. Well, we know at the point of intersection, the value, the height of both graphs are the same. What do I mean by that? Would you agree that I can rewrite f of x as y equals x plus 1 and g of x as y equals minus x plus 3? Sure, I can do that. So now notice that one f is going up and g is going down. They are intersecting at one particular point. At that point, both graphs have the same height. Because both of those graphs have the same height at that particular point, now I can go ahead and set them equal to each other. I can say x plus 1 equal minus x plus 3. Well, if I add x to both sides of this equation, so I'm going to get, say, plus x here, plus x. I'm going to get 2x plus 1 equal 3. I'm going to go ahead and subtract 1 from both sides, minus 1, so 2x equals 2. Divide both sides by 2, and this follows that x equals to 1. So at x equal to 1, they intersect. So what if I want to find the coordinate point? Well, I know that at x equals 1, they meet, they intersect. What's the y value at that particular point? Well, I can substitute that 1 in here or in here. They would give me the same answer. Why is that? Once again, because they both have the same height at that particular value, at that particular point of intersection. If I put 1 in here on f, 1 plus 1 is 2. If I put the 1 in g, minus 1 plus 3 is 2. So point of intersection for f and g of x is, let me do all in blue, 1, 2. Let's do another example. Let's do another two just linear functions, f and g. Suppose f of x equals 2x minus 4, and suppose g of x equals 6 minus x. Once again, f is going up, g is going down, it has negative slope, so they're going to intersect at some point. And we want to find that point algebraically. I'm going to set f and g equal to each other, 2x minus 4 equals 6 minus x. Once again, at the point of intersection, both f and g have the same height, same y value. So now I'm going to go ahead and add x to both sides of this equation. So plus x here, plus x in here. So I get 3x minus 4 equals 6. Add 4 to both sides of this equation. So I have plus 4 here, plus 4 here, and that gives me 3x equals 10. And x equals 10 over 3. 10 over 3. Okay, now I want to find the value of y. So So x is 10/3. What is my y value? Well, I can plug it in on F or in G. It doesn't matter. It's, that gives me the same answer. Let's try F. F of 10/3 equals 2 times 10/3 minus 4. So that equals to 20/3. I need least common denominator. 4/1 is the same as 12/3, and that gives me 8/3. 8/3. Okay. And remember, we said that you could also plug the 10/3 in g of x. Let's just try it just to make sure that I get the same value. So now g of 6, g of 10/3. Sorry about that. G of 10/3 equals 6 minus 10/3. Least common denominator is 3. 6/1 is the same as 18/3 minus 10/3. That gives me 8/3. So notice that F and G gave me the same answer. Okay, so some of you probably at this point say that, hey, in my math classes in my high school or in my previous courses, I've seen like functions that are not necessarily aligned, they're curved. Can we do an example of that? Sure, let's do it. Suppose this time let f of x equals x squared minus 4x plus 3. And let g of x equals just 3. Okay, so what is I have, f of x is like a parabola like this. G of x is just a straight horizontal line like this. So notice that they are going to be meeting, intersecting at 2 points. Let's find what those 2 points are. I'm going to say that now x squared minus 4x plus 3 equals to 3. Now, notice if I subtract 3 from both sides of this equation, I get x squared minus 4x equals 0. On the left-hand side, I can factor an x out. So x times x minus 4 equals 0. Using zero product property, I can claim now x equals 0 and x minus 4 equals 0. Well, this x equals 0 is already solved. I don't need to do any work for it. For x minus 4 equals 0, I'm going to add a 4 to both sides, so x equals 4. So notice that now we said that they are meeting, intersecting at 2 points. One point is x is 0, comma something. The other point is 4, comma something. Okay. So notice that now I can plug in the 0. Okay, if I plug in the 0 in f of x, 0 minus 0 plus 3 just gives me a 3 in here. And if I plug in a 4 in f of x, I also get 4 squared is 16 minus 4 times 4 is 16. So that gives me 16 minus 16 is 0. So I have another 3. I'm left with a 3. And that's not, I'm not surprised by that on the least bit, because I know g of x equals to 3 at all times. So, by just looking at it, I could tell that the value of y for both these are the same, 3. And I could tell that from my graph. We had a parabola, and then we had a horizontal line. Let me make it a little bit better. Let's do one last example, make it just a little bit harder, just for the sake of discussion. So let's say this time f of x equals x to the second plus 5x minus 3. And let's g of x to be just 2x plus 1. So notice that now I have a parabola here, and g of x is a line, slope is 2, y-intercept is 1, something like that. So again, I have 2 points of intersection. I'm predicting 2 points of intersections. Well, let's find that algebraically. X squared plus 5x minus 3 equals 2x plus 1. I'm going to go ahead and subtract 2x from both sides. Minus 2x here. Now I have x squared plus 3x minus 3 equals 1. And I'm going to go ahead and subtract 1 from both sides now. This one, minus 1. And now I have x to the second plus 3x minus 4 equals 0. I have a trinomial. I'm going to go ahead and factor these two, x plus 4, x minus 1 equals 0. Using zero product property, I can claim that x plus 4 equals 0 and x minus 1 equals 0. In here, if subtracting 4 from both sides, minus 4 and minus 4, I get x equals negative 4. Here, plus 1 on both sides, x equals positive 1. So the 2 points of intersections are negative 4, something that I'm going to find out, and 1 comma something. All right. So let's plug in negative 4 into g of x. 2 times negative 4 is negative 8 plus 1 is negative 7. And plug in 1 into g of x. So 2 times 1 is 2 plus 1 is 3. So we successfully found the points of intersection. And listen, once again, you could plug the number, this 1, plug it into f of x. Let's try it. F of 1 equals 1 squared plus 5 times 1 minus 3. That equals 1 plus 5 minus 3. Okay, so 1 plus 5 is 6. 6 minus 3 is 3, and that's what you have in here. Let's try negative 4 and put the negative 4. Let me change color. F of negative 4 equals negative 4 squared plus 5 times negative 4 minus 3. So that equals 16 minus 20 minus 3. Well, 16 minus 20 is minus 4, and minus 3, I get minus 7, and that's, so really, it doesn't matter which one you substitute your x value to get the y value. It's just that I felt g of x was faster because it's a linear function. Okay, thanks.